Okay, in this screenshot we're going to be establishing areas of triangles and parallelograms. So just as a quick recap, in front of us here we have a rectangle. The area for a rectangle is length times width. So what's the difference between a rectangle and a parallelogram? Well, to the side here we have a parallelogram. The reason they call it a parallelogram is because this line is parallel to this line and this line is parallel to this line. So the language has got to change a bit. Instead of doing area equals length times width on a parallelogram, we've got to find the height of the shape instead. Here's the word height. So our height, to find the height of a parallelogram, we've just got to look for this line that identifies at a 90-degree angle to the baseline. So therefore our language changes to area of a parallelogram will equal base times height. So instead of being length times width, it's now base times height. So we'll practice one of those. We'll come over here to our parallelogram. Here's one with some dimensions on it. First thing we need to do is identify on this parallelogram, which shows us it's a parallelogram, that's parallel to that parallel, that's parallel to that parallel. What is our height? Here it is here because the line here has a 90-degree angle indication to this baseline. So therefore, area of a parallelogram equals base times height, and in this case our base we identified with that 90-degree angle is 16 and our height with that 90-degree angle is 10. So this is irrelevant information. So 16 times 10 is 160 and the units is centimeters, but remember it's surface area, so they're squared centimeters. So what happens if we come across a triangle? Well, if I go back to my good old rectangle here, it might point it out a bit easier for you. If I look at this rectangle, let's just pretend it was base times height. Okay, what happens if I turn it into two triangles? It's been cut in half, okay? So it is now, we now have half of that base times height. So our rule would change. So when I go over to my triangle, we now need to look at it as half of a parallelogram. So here's a triangle. If I was to draw that as a proper parallelogram, it would come out here somewhere like this. And then we would have our parallel lines and our parallel lines going this way. But it's been chopped in half because it's a triangle. So we follow the same rule. Area of a triangle, I'll just make it nice and short. Area of a triangle will equal the same as a parallelogram, base times height, except the difference is I have now chopped it in half. So we have two triangles in that parallelogram. So therefore I've got to, base times height, chop it in half by dividing it by 2. So first of all, find our height. Here it is here, because the 90-degree angle here indicates that's our height, and it's also in line with our base. So our height is 6 centimeters and our base is 10 centimeters. So base times height, and then remember it's a triangle, so we chopped it in 2 or halved it, divided by 2. So base times height is 60 divided by 2. So therefore it is 30. And the unit is centimeters, and they're still squared centimeters in surface area. Okay, we're going to try a few of those in our textbook.